Question 3. The circle K has center 1, minus 2. So we have the center at the point D. And we take this one as the radius. And we're told the chord AB, and AB is 4 root 3. D is always the midpoint of the chord. So this is 2 root 3. So we just need this length here. So what's CD? We want to find the radius. CD is equal to the square root of the change in x to be squared. 1 to 3 is going to give me 2 squared. This 1 and this 3. The change in y, minus 2 to plus 2 is 4, which is equal to root 20, which your calculator will just give you the answer straight away to be root 4 by root 5, which is 2 root 5. Now I'm looking for the radius here. CB is equal to the radius. So R is equal to the square root. We have the two straight sides. 2 root 5 squared plus 2 root 3 squared, which on your calculator is going to give you 4 root 2. Part B, we're asked to show that these circles touch externally. So we got to show that the distance between their centers is equal to the two radiuses added together if they touch externally. So S here, which is the center, is going to be 7, 13. That's my center. My radius is going to be root 25, which is 5. For this circle, I'm just going to write it in the same format. X squared plus 4x is x plus 2 squared, but I don't want that 4 that I've brought in. And I have y squared minus 2y, so y minus 1 squared, and I don't want that 1 that I brought in, the minus 1 by plus 1. So I brought in 5 that I don't want. I want minus 95, so I have to take away 100, or you write as equals 100. So the center is minus 2, 1, and my radius is the square root of 100, which is 10. So R1 plus R2 is equal to 5 plus 10, which is 15, and the distance from 7, 13 to 2 minus 1, or minus 2, 1, has to be the same. The square root of the change in x, minus 2 to 7 is 9 squared, and the change in y, 1 to 3 is 2 squared. That's a 13, not 3, so 12 squared, which is equal to 15, which is equal to R1 plus R2. Now there's an infinite number of circles which touch circle C externally at the same point that S touches C. Find the coordinates of the center of one of these circles apart from circle S. Okay, let's do a sketch here. The two centers are minus 2, 1 and 7, 13. So minus 2, 1 and 7, 13. Let's see, these are the two centers. The ratio, which is the bigger radius, the minus 2, 1 has the bigger radius. So let's say that that's the edge of that circle, and this is 10, and that's where the circles touch, and that's the center of the next circle here, and this is 5. So from this point of contact here, just change the color. From this point of contact, there's an infinite number of circles that touch at the same point that S touches C, which touch C externally. An infinite number of circles which touch C externally, and C is this one here. So there's an infinite number of circles which touch. So it's going to be touching at this point, and the center would have to be along this line to keep their radiuses along the same line. So we just have to find another point somewhere along this line, and that's why there's an infinite number. It could go on forever. So let's have a look at finding a point along that line. So we have minus 2, 1. We have 7, 13 up here. This big point here is 7, 13. So to get the point of contact, we have the ratio here. 10 to 5 is 2 to 1. So x is jumping by 9. Minus 2 to 7 is jumping by 9. So 2 to 1 is a jump of 6 and a jump of 3. So minus 2 goes to plus 4, and then a jump of 3 will get me to 7. So that's correct. So 4. And then y is jumping from 1 to 13, which is 12, in a ratio of 2 to 1, 8 to 4. So 1 jumps up 8 to 9, and then another 4 will get me to 13, which is correct. So this is the point of contact. So to have another point along this line, we would need the same ratio on the jumping. We get the slope of this line, we find another point along that line somewhere. So there's a few ways to do this. I think if we get the equation of the black line, we can get any point along the black line that's in this direction. So what's the slope of this line? The slope is change in y is 12 and the change in x is 9. So the slope of this line is 4 over 3. So the equation is y minus, well, we use the point of contact, y minus 9 is equal to 4 over 3 times x minus 4. So 3y minus 27 is equal to 4x minus 4. 4x minus 3y is equal to minus 23. You see the error, that should be 4x minus 16. Just come back over my work. So we have 4x minus 3y is equal to minus 11. Just double check each line as you go through it. So we can get any other point along this line. We're here at the point of contact at 4. So if x is equal to 5, we'd have 4 times 5. This is when x is 5. What will y be? Minus 3y is equal to minus 11. 3y will be equal to 20 plus 11, 31. So y is equal to 31 over 3. Is there any point that will give us an integer center? Well, let's have a look here. Let's just do a little bit of trial and error in our heads. So I think if x is 7, that might work out evenly. We just want y to be divided by 3, so I just have to go up another 2 to get 33 over 3. So if x is 7, 4 7s minus 3y equals minus 11. 28 minus 3y equals minus 11. Minus 3y is equal to 39. Plus 3y is equal to 39, so y is equal to 13. So 7, 13, you can see is the next center. That's the one we had there. So it is on the line, just to double check that. So my other point, this is going to be the center of my circle. 5, we could go along any other point along there. If we wanted to put in 6 for x or 8 for x, and you'll get another value for y.